Okay, so hello everybody. My name is Max Di Penta, and this session is about reuse and agility. We have 6 papers of different type in this session. So we will going to have a 5-minute presentation for each paper, and we'll typically keep the question for the end. So the audience can either keep the question for later and then open the mic and ask the question, or if you wish, you can also start to write your question in the chat. But if you are doing so, please either write the speaker name or the paper number, like paper 1, 2, 3, 4, and so on, so we know to whom you are asking questions. So we are going to start with the first paper. The first paper is being presented by Chao Liu, and the paper is titled Code Matcher, Searching Code Based on Sequential Semantics of Important Query Words. Please. You're mute. You are still muted.
Okay. Can you hear?
Yes.
Okay, sure. I'm Chao Liu from Chongqing University, and present our work called Matcher, searching code based on sequential semantics of important keywords. And searching and reusing existing code from large-scale repertoires can improve software development productivity. And we can see that the GitHub commonly returns numerous irrelevant and useless code. And we can see that existing code, such as the information retrieval model, works fast, but the accuracy is bad. The deep learning models work slow, but it has 3 advantages, such as understand irrelevant keywords, capture sequential relationship between words, and learn matching relationship. And our goal is to fuse their advantages. We here present our code matcher. From step 1 to step 4, we build index for the code base, such as the information retrieval model. From step 5 and 8 to step 8, we simulate the advantages of deep learning models, such as collect metadata, address irrelevant noise words and stable words. And we perform further search to retrieve some candidates from the indexed code base. And we finally remove some redundancy and re-rank the code list according to our designed algorithm. An example is that a query converts an input string to a string. We analyze the token metadata, such as property, frequency, and importance for each keyword, and perform the further search for code search. And we re-ranked the code list and put the first code to the list. We compared our code matcher with 3 step-outs and tested on our code base over 60 million Java methods. Our experiment code matcher outperforms 2 deep learning models and 1 information retrieval based models. And the code matcher runs fast with only 0.3 seconds for an query and without any time-consuming training. And all the components are less necessarily required. And we also proved that code matcher substantially improving GitHub and Google search. We also did some analysis of the results of our code search. We found that this tool works well because it can precisely match the semantics of the code method name. We also showed that the conciseness and the completeness of the searched code is better than the baselines. And we observed that the deep learning works better in our code base because because of the larger scale of code base and the out of vocabulary issues. And we analyzed the importance of the word sequence. We found that most of the queries showed the importance, but many baseline didn't consider this problem. And this is our work. Thank you very much.
Thanks a lot. So I took note of some questions, but I will ask the questions later. And now we move to the second speaker, Joseph Heiderup, and is going to present another journal first paper titled Prezi from Package-Based to Call-Based Dependency Networks.
Yes, thanks. Sorry. Hi. So yes, I'm going to talk about Prezi. So this is a journal first paper at MC this year. This is work together with Moritz Belle, Konstantinos Gianfoli, and Gorgos Gousios. To sort of very briefly talk about, this is about package repositories, and many of you might be using, for example, like like NPM or like the Cargo packaging tool. And what we have seen like in recent years is that these repositories keep going very quickly. So for example, you have like on Rust on average like 6 packages per day, and in NPM it's almost like nearly 2 million packages with an average growth of 52 packages per day. And a problem with like package repositories is that we would kind of want to understand, for example, problems like related to leftpad or other things or incidents that generally happens. And what we proposed in this work is that we try to analyze this from a network perspective. So and also using call graphs. That's like the sort of main idea here. And for example, if you see here that you have 3 packages, one app, lib1, lib2, and when you let's say like do package analysis, like usually you only know that, for example, if there is a vulnerability called in a function called intern, if you do reachability analysis, you can see that there is a direct path. But in another case, if it's unused, you know that there is no vulnerability. But the problem is that when you do this on meta level, you don't really have this information. And this is something that we did in this work. And we've also kind of curious to know what is like really the difference between this and, let's say, like doing it on metadata-based perspective. So what we did is that we looked at dependency relationships from metadata perspective, but also from a call perspective. And we wanted to know what is really the difference between those two levels. And for direct dependencies, we found that it generally sort of approximates each other, which means that roughly, let's say, like if you have a dependency tool that shows that you're using this type of dependencies, most likely you're also calling those dependencies as well. But when it comes to transitive dependencies, the story is much more different. And we found that, for example, that packages are not indirectly calling 60% of its resolved transitive dependencies. Yeah, I mean, I'm not going into this. You can find more in the paper, but there are a lot of discrepancies between when it comes to transitive dependencies. And then sort of coming to like the main conclusions, like when should you use a metadata-based network or when should you not use it? So we found that you should generally use it for direct dependencies. Constructing call graphs for every single package of a repository is very expensive. So there's like a huge cost benefit. And also you have to think about the soundness as well. So that could be like a problem because package repositories are not homogeneous. There are a lot of different packages. Some might have code generation, some might do, use some other dynamic features. And when should you use call-based networks? Well, in the picture show that you should really use it when it comes to transitive dependencies because what we know is that when we look at call relationship, the context plays an important role because you don't call all functions in your direct dependencies, and that also leads to that you're not calling all functions of transitive dependencies. Sometimes you don't even call those transitive dependencies. And the other point is that when you start looking into the code, you also get much higher actionability, and of course you get more precision. So yeah, if you want to know more about this work, so check out the Prezi paper. That's all for me.
Thanks a lot. Okay, so we move to the third presentation. Again, it's a journal first paper and is going to be presented by Daniel Russo. Daniel, are you here? And the paper is titled The Agile Success Model, a Mixed Method Study of a Large-Scale Transformation.
Hello, everyone. Can you hear me?
Yes.
Yes, you can hear me. I'm now trying. Can you see my presentation?
Very small, but somewhat.
It's very small. Yeah, I mean, apologies, but no, I don't know. Well, anyways, it's just a one-page slide. Since I only have 5 minutes, I hope that I can talk a little bit about this research experience that was actually quite long, who started from my PhD and then basically went through my postdoc and assistant professorship position. I had this rather unique opportunity to study a mission critical organization in Italy, where the initial approach was to do a mixed cognitive theory and ethnographic approach at this organization. The final result of this initial stage of research was the identification of a set of variables who influence project success in agile transformation processes, which is the first picture you can see, where another relevant element was this distinction into three main managerial layers. So the first layer is composed by the top management commitment, who have then a mid management layer made of product owner and scrum masters, and then a final stakeholder implementation layer by the developer skills. In addition to that, but this is highly specific to the organization that I was studying, were the external drivers who basically pushed towards this kind of transformation. A highly relevant aspect that I identified during the qualitative kind of research was the distinction between both a social and a technical skill elements, since I have observed like developers with either poor social or poor technical skills being fired from a project because they were not able to align with the rest of the group. My second, the second part of this investigation was a deductive process, or deductive investigation, where I use partially square structural equation modeling, where I try to operationalize the first research model into a structural model, and the final result you can see in the second picture that I have here for you today. And now the first thing that can be seen is that eventually the developer skills has been collapsed, right? So I mean, apparently, even though in the observed organization these two skills were separated entity, through cross-sectional studies, I was able to identify that this was only specific to the organization that I was studying, and not present and not generalizable in the general agile software engineering population. In addition to that, the result were the identification of the specific kind of relations and how this relation impacted especially project success. In this specific regard, also with an important performance mapping analysis, I was able to identify that the developer skills had the greatest role to the final project success. And the second most critical aspect was top management commitment. So if I have to provide, a very few sentence conclusion, I would say that in order to have a successful agile project transformation, alongside top management commitment, organization should stress the development of both social and technical skills of their developers. And with that, I'm in my 5 minutes. Thank you so much.
Thanks a lot. All right. So we still keep talking about success of agile projects. This time, yes, again, we have a journal first paper being presented by Elvan Kula, and the title of the paper is Factor Affecting One-Time Delivery in Large-Scale Agile Software Development.
Thank you very much, Max. So hi, everyone. I am Elvan Kula from TU Delft, and I'm here to present our journal first paper. This was, the work was performed as part of a collaboration between TU Delft and ING, the Dutch bank. I worked on the paper together with Erik Greuter from ING and Arie van Deursen and Georgios Chousios from TU Delft. So before I tell you more about the paper, I first want to remind you that late delivery and cost overruns have been common problems in the software industry for decades. So on average, software projects run around 30% over time, and this percentage does not seem to have decreased since the 1980s. Delays are caused by deficiencies in effort estimation during project planning. During project planning, and effort estimation is especially challenging in the software industry due to the fact that software projects are complex socio-technical systems. Effort estimation remains an important topic, as improving it has a large economic benefit for software organizations. So it can help companies to reduce delays, to improve customer satisfaction, while also enabling a more efficient resource allocation to reduce delivery costs. And to improve on-time software delivery, we need a good understanding of the factors that affect the software development efforts. Previous research has identified a large number of factors that influence efforts, but which factors have the most impact is not clear. So we lack an understanding of the relationships between these factors and how they impact on-time delivery. Effort estimation is also a major challenge in agile development settings. So a particular challenge involves combining the short-term iterative agile planning setting with the business needs for the long-term planning of larger pieces of functionality that we often refer to as epics. Epics are, larger pieces of functionality. It can be split into features, which can then be in turn split into user stories. And in our paper, we focused on delays at the level of epic deliveries. So the overall goal of our paper was to identify the most relevant factors and interactions that affect schedule deviations in large-scale agile software development. And we had two research questions, one focused on factor identification, the other one on factor validation. Identifying and investigating influential factors can lead to very important insights on what data and techniques are needed to become more predictable at delivering software. And this can help software organizations to design more effective and efficient strategies for scheduling and also risk management. And such knowledge can also guide future research on building, evaluating, improving effort estimation techniques and tools. To answer our research questions, we performed a mixed methods case study at ING, a large Dutch bank. We developed and sent out 2 rounds of surveys to software experts at ING, and then we also applied data triangulation. So we analyzed lots of backlog management data, code quality measurements from 200 teams to corroborate the respondents' perceptions. So I will give you a short peek at the results. So from the survey responses, we identified 25 factors that are perceived to affect on-time delivery in large-scale agile settings. A few new factors emerged from the survey data, including team familiarity, agile maturity, and several organizational factors. And the factors requirements refinement, task dependencies, and organizational alignment are perceived to have the greatest impact. Whereas in our analysis of the repository data, we see that proxy measures such as project size, team familiarity, developer experience, and the historical delivery performance have they have the greatest impact. They can help explain a large degree of the schedule deviations in the deliveries at ING. So based on the further analysis of the survey data, we extracted direct, indirect, and contributory types of relationships between the factors and on-time delivery. And we organized our findings into the form of a conceptual framework that is shown here. It captures how the perceived influential factors relate to on-time delivery. And practitioners can use our conceptual framework to identify and manage the risks associated with on-time software delivery. And our results suggest multiple paths for action that can be found in the paper. And based on our findings, we also identified challenging areas related to security concerns, to the scalability of agile methods. And all of these areas are crucial in order to become, to understand better how we can become more predictable at delivering software in agile settings. And with that, I would like to conclude my talk.
Oh, thank you very much. So we move to the next paper, 5th paper in this session, and this paper is going to be presented by Artem Kruglov, and the paper is a software engineering practice paper, and the title is Issues in the Adoption of the Scaled Agile Framework. Please. Artem? Artem, are you here? I see you here, but... Okay, let's see if Artem reacts, otherwise. Okay, here we go. Hello, Artem.
Okay, hello one. So my name is Artem Kruglov. Let me present our work titled Issues in the Adoption of the Scaled Agile Framework. I have only 5 minutes, so let's try to be very quick. And first of all, a small recap on SAFe framework. It's based on, first of all, the four core values, which are building quality, transparency, program execution, and alignment, and also
Can
lean
you
agile
try to
mindset.
go to presenter
This is
mode?
its basement, and then it defines also 7 core competencies, which form 4 levels at which we have different processes and practices described in the SAFe. These 4 levels are team level, then we have program level, where we define the concept of agile release trains, and the number of teams work together on making some increment to the big project or big solution. Then on the top of program level, we have solution level, where we have a number of agile release trains, and at the top, on the top of the top, we have portfolio level, where the company strategy is defined. And if we go through the literature which we could browse on internet, we could find pretty much criticism of the SAFe. First of all, there are a lot of criticism on its complexity, and it's hard to understand this framework. But moreover, there are many sources, especially from grey literature, that claims that SAFe is not a agile framework at all, and it's more like a waterfall-like structure. So the idea of our research was to perform systemic assessment of the SAFe in terms of whether it's a agile framework at all or not. And we try to answer 3 research questions in our survey. First question: what are the crucial success factors of success for adopting SAFe framework? Could SAFe hinder agility, in fact? And what are typical effects of SAFe? And our research was based on basically that has two steps. First is multi-vocal literature review, where we analyzed 19 papers out of 178 using both white and gray literature. And on the basis of results of multi-vocal literature review, we perform also a survey with 25 participants. And after it, we compare the results and perform the systemic analysis based on these 2 directions. So the results were the following. Results of multi-vocal literature review show that success factors of SAFe are appropriate staffing, leadership support, and measuring changes, the main success factors. Then go into a question on hindering fragility by SAFe framework. We got the following possible aspects of SAFe which conflict with agility. They are team structure, too detailed methodology, complexity, inability to improve, and the requirement for alignment in terms of direct decisions, not on a creative work of teams and team members. And effects of SAFe which were found in literature are positive effects. Alignment, yes, on contrast with previous research question. Ability for continuous improvement, frequent deliverables, and improved quality of the product, of the code. And negative effects were big upfront planning, as it seems for some authors, difficulty or complexity of the framework, challenges for continuous improvement, and hierarchical decision making, which again refers to alignment. And with the results of multi-vocal literature review, we moved to the survey. And the first set of questions were dedicated to the research question on success factors of SAFe. And from the survey, we got the following result: that leadership support is the main factor of success, followed by such factors as synergy of business and development, culture, competent staff, and creating pilot teams to test how this frameworks works at all. Factors which hinder agility according to the survey. You could see that we asked the same questions as we got from multi-vocal literature review and asked participants whether it's true or not. And we could see that for too complex framework and not adaptable processes, we got more or less approval of this concept. But for supporting of learning and improvement and for hierarchical alignment, most respondents said that they strongly disagree with these statements. And the final research question, according to from the survey, positive and negative effects also were proved. We got the approval of results which we got from multi-vocal literature review: the better productivity, big picture, coordination, quality of the product, etc. And negative effects, the main negative effects is the requirement for additional resources. So overall results shows that SAFE requires commitment from the whole organization to be successful, not only from the top management, but from team members as well on each level of organization. And which is more important as a result of our research, the second research question, which is about hindering agility. According to the survey, it seems that SAFE not hinders agility, but vice versa. It appears to expose its essence as it requires additional commitment and involvement from each parties, which in fact the part of any agile culture. It's much more complex than a waterfallish structured waterfallish hierarchical culture. So that is why the result shows that indeed SAFE is agile and it exposes agile practices and behavior in the companies. And benefits and drawbacks of SAFE, also a result of multivocal literature review, were approved by the survey. Benefits are better productivity and quality of the products and processes, and challenges in terms of extra resources, both direct, additional source, additional personnel training, and indirect, as far as we need to face with feelings of some individuals that we has less autonomy, more strict structure in the SAFE, but it's feelings. It's not a real situation. As far again we got from second research questions that SAFE do support agile in a nutshell. And as a conclusion, I could say that this study that we performed was fundamentally exploratory and observational. And of course, it's preliminary study because the survey has not too many participants involved in. And we do hope that the results of the study will be used in further researches by researchers in further research and development of their own frameworks or prove some concepts. And also, we do believe that such studies should be performed also for other popular frameworks, agile frameworks applicable in large organizations such as large scale Scrum, Scrum at Scale, Nexus, and other popular frameworks. With it, I'd like to stop my presentations. Thank you for your attention.
Thank you very much.
That's all.
Okay, so we go back to reuse and let's say more low-level analysis. We have the last paper for this session. This paper is going to be presented by Hitan Chai. This is a technical track paper and is titled Cross-Domain Deep Code Search with Few-Shot Learning. Please.
Hello, sir. Can you hear me?
Yeah.
Okay. Okay. Hello, everyone. My name is Yitian Chai from Shanghai Jiao Tong University. Today, I'm going to present our work, Cross-Domain Deep Code Search with Meta-Learning. The past few years have witnessed a rapid development of deep learning-based code search, in which a bimodal deep neural network is trained based on a large parallel corpus of code and natural language. The deep neural networks computes vectors for both the query and code snippets in the code base, and then searches code snippets based on their vector similarity. A major challenge for deep code search is the adaptation of deep learning model to domain-specific languages. State-of-the-art code search methods are mainly designed for common languages, such as Java and Python. They rely heavily on the availability of large parallel data to learn the semantic mappings between code and natural language. Here is an example. A programmer asks the well-trained neural network for a code snippet using Solidity to sort an array. Although the neural network is well-trained, with a large amount of data, it can understand well what is Solidity. A key idea to solve this problem is the few-shot learning. Few-shot learning is a machine learning technology that aims to quickly adapt the trained model to new tasks with a small number of training samples. Since deep learning models have already know how to sort an array in other languages, we can simply provide a few examples to adapt the model for a new language. In this paper, we propose CDCS, a novel cross-domain deep code search method using meta-learning. In addition to pre-training and fine-tuning, CDCS adapts a few-shot meta-learning algorithm called MAML to learn the good initialization of model parameters, which can best be used in a domain-specific language. CDCS involves 4 steps. We first pre-training the model with a large corpus of multiple common languages such as Java and Python. Then we perform meta-learning to adapt the pre-trained code representation model to the target domain. Finally, fine-tuning the model on the code search task and evaluating it. The pre-training phase aims to learn representation of code and natural language from a large corpus of multiple common languages, such as Java and Python. We pre-train using the task of Mac-language model. Next, we perform meta-learning to adapt the pre-trained code representation model to the target domain. We employ the MAML, which is a typical algorithm for few-shot learning. It learns a set of initialization parameters using large data of common language, and then trains a new code search model on a small domain-specific language starting from the found initial parameters. And in the fine-tuning phase, we apply CDCS to the code search task in the target language. We fine-tune the model on the code search task, which is also regarded as a binary classification problem. In our experiments, we pre-train our model on Python and Java, and transfer the model to Solidity and SQL. We compare the CDCS with 4 baseline, and we can see that CDCS outperforms the baseline models in terms of all metrics, especially the top one accuracy and MRR. We also present the performance of CDCS under different data sizes. In conclusion, in this paper, we present a cross-domain deep code search approach that adapts trained models on common language to domain-specific language. Using meta-learning, CDCS demonstrates good strengths in few-shot learning for domain-specific code search. That's all. Thank you for listening.
Thanks a lot. Okay, now we have time for questions. And well, first of all, I would like to hear if there are questions from the audience. Any question to the speaker, to the speakers, to anybody? So, Elvan, I guess this question. This is a question for Elvan from Daniel. Do you have any insight into whether team diversity and delivery timelines correlate?
Yes, thank you, Daniel. Very nice question. So we've seen that, there's actually a trade-off that we have to make there. So on one hand, team stability and team familiarity is very important. So we actually need to avoid the turnover of team members to make sure that we have a stable environment, and that would actually contribute to on-time delivery. But at the same time, it's also important to have a good level of engineering experience and technical knowledge in the team. Especially the number of senior members is something that definitely contributes to on-time delivery. So there's actually, it is difficult. On one hand, you want to make sure that you have, you keep the team members that you have, but you also want diversity in your team and make sure that you have a good mix of skills there. So I think that's, that's a very, very good question, and indeed something that we saw in our results.
Okay. Since we are asking question to Elvan, I would also like to ask a question. So, as you of course know, the specific domain that you have investigated is a domain in which it may be or may not be easier to estimate time and effort for feature development. So what I would like to know is how specific are the factors that you found to that domain, which is pretty much the financial or banking domain, if I understand correctly, and how those factors may change to other domains, especially if you think about domains where the results of the development may not be so obvious, where there is, for example, a little bit more research involved, or, for example, think about video game development where there is more creativity and it's not clear whether things go toward the direction that one has planned. So let's say what I wanted to say is that maybe development in the banking can be a little bit more straightforward than in other domain, and so I'm wondering whether things change in other domains.
Yeah, that's also a very interesting question. I think it's hard to make statements about how the factors would change in other settings. So I think we need to do more research on that. But we found 25 factors that are perceived to affect on-time delivery. Many of them were also found in previous in literature, in previous works. So we know that they are generalizable to other settings. We also found a few new factors that we would have to further investigate in other settings as well. But we do think that some of these factors, especially some of those that were ranked very highly. So, for example, security testing, the impact of organizational stability, organizational politics as well. It's of course a bank. It's a traditional environment. So we think that those would be ranked higher in a banking company than at other settings, for example, in game development. Yeah.
Okay. Then we have a question for Joseph from Bokwin. The question is about how the dependency analysis was developed without a precise pointer analysis, or whether you indeed did the pointer analysis. So how the dependency analysis worked without a precise pointer analysis.
Yeah, so thanks for the question, Boki. So yeah, indeed, we didn't do like a pointer analysis-based call graph construction. What we did instead was more like class hierarchy analysis or like rapid type analysis. So going through like the questions you have, like the pointers you have, the first one, yes, we did resolve function from adequate. So how did we do that? Well, so whenever we built a call graph, we knew about the functions that are going to other packages, right? And what we basically did is that we built call graphs like from individual packages and then stitched them together. So that's sort of like the approach that we took. And that's also like the way we dealt with indirect calls. However, we solved dynamic traits, but we did not do function pointers, and I think we didn't even do drop shims. We did have, let's say, like also like this monomorphized instances as well. So what we did, because I don't know how Rust specific this is, so I mean we did this at the mirror level yeah. So initially we did first like at let's say like by building like the LLVM like format, but the problem with the LLVM format is that you don't have all the type information. So then we hooked into the mirror instance, and that's basically where we gathered all type information to build more or less like a CHA based call graph.
Okay, thank you.
Yeah, thanks.
Thank you. Other questions? Not yet. So I have a question for the first speaker, Charlie. So I would like to better answer how you used the important keywords to reformulate the query, whether you used an approach like the Rocchio relevance feedback by weighting more of those keywords or something else. So how did you reweight the query using those important keywords?
You mean why use these important keywords? Am I correct?
Yeah, how the important keywords were used or can be used to improve the retrieval. Do you weight more? Yeah.
Yeah, the keyword is very important for the code search. We firstly observed from the data and the query, and especially the code search behaviors. We observed that developers usually use the verb or phrase, just like a noun, verb, and some programming programming words. And that is very important to form a query. And the sequential relationships is very important. But the deep learning models and the other models didn't strictly follow the order of the important words. So we just build the rules to extract the order of important words that will precisely match the semantics of the query and the code.
Okay.
Yes.
All right. Other questions? Not yet. Okay. So I have a question actually for both the first and the last speakers, so for Chao and Hitan, because, well, in both cases, you're kind of trying to use deep learning for code search. And especially for the last paper, I guess one motivation is that if you use traditional information retrieval, different domains, especially different languages, have different lexicon and different keywords. I was just wondering whether instead of using a complete deep learning model, just relying on a word embedding representation would be sufficient, or whether the word embedding could be combined with your approach, or whether you already combined word embedding with your approach. Any of either the first or the last paper. So either Chao or Hitan can answer to my question.
Well, I think as our work is information retrieval model, and we found that the code search tools works because the words such as a query and the machine learning they represent in the same way, because they are all natural languages, and the embedding methods used for natural language processing can help this. And for the query and the code, they implement in different ways, and the tokens and will be different. And I think the word embedding, in my opinion, the word embedding have some difficulties in marrying the equivalence of the query and the code. So the key is the quality of the training data, I think. Yeah.
Okay, thank you. I don't know if also the last speaker would like to comment on this. Hitan. No. Okay. All right. Maybe I have. Yes, please.
In our research, is that question about the embedding?
Yes. Yes.
In our research, we try to embedding through the embedding to extract information from the task itself, not only for the programming language like the information in Python or information in Java. We use the meta-learning methods to extract the task information. Yes, the code search task, the information about itself from the Python and Java, the large corpus of data set.
Okay. Okay, thank you. I would also like to ask a question to Daniel. So basically, it's more a clarification question. I would like to know more about how did you observe the process in the companies? What kind of methodology did you use? Did you use semi-structured interviews, questionnaire, ethnography? Did you analyze documents, all of them together? What you did?
Yeah, thank you for the question. It was a mixed approach.
Yeah.
It started more like an ethnographic approach, so through observation. It also started research started with starting to having first of all an understanding of the process going on from the top management of the organization. Afterwards, through observations, once some kind of patterns have been identified, I run a number of semi-structured interviews and using a new grounded theory approach, which is chain methodology, developed by Denis Gioia, which is now considered to be the mainstream grounded theory approach, at least for in the management community. And using this approach through a number of iteration until theoretical saturation was reached, right? So this is how the first model came, also analyzing also documents of our organization itself, yes.
And by the way, I see, of course, you are a single author of your work. How challenging was to do this alone? Because typically, whenever
Yes.
possible, people try to do this with multiple evaluators, and I guess it's way more challenging to do it by from a single person.
Yes, I think also a very good observation. So first of all, this was, I would say, one of my main projects of my PhD. So it's clearly also something where I dedicated a number of years also after the PhD finish. So this also helped me to, you know, again, not only to reach theoretical saturation, but, you know, also to reflect about the single interactions happening, also going back and forth, especially to the top management. That was, you know, always a very important point, right? Because one of the points of grounded theory is not that, you know, you go, you do whatever you do, and then you say, okay, so that's my model, and now I'm happy, and now I'm done, and it's, you know, right? So, I mean, unfortunately or luckily, you know, no judgment based, but qualitative investigation are extremely long. I would say very complicated, you know, because the identification of the teams and this whole process, right? So basically from verbatim into aggregate dimension is an extremely long process where, you know, you have to iterate multiple times. But I think it's very worthy and also personally very rewarding when, you know, basically you put your model into a structural model and then you actually see that, you know, whatever you have observed in reality, basically it's also supported by data and is therefore also generalizable.
Okay, thank you very much. So this is very important observation and discussion because, especially there may be many cases in which you are alone and they want to do this kind of study. So it is possible. So your work says that it's possible, but be prepared to do a lot of interaction and it's going to be very
But
long.
I wouldn't do it now.
Yeah. Okay,
it was
thank
a very,
you.
very
So,
good PhD training. I mean, it's
yeah,
definitely recommendable for PhD students. Yes.
yeah. Okay, so I will also like to ask a question to Artem. So, related to the self model that you have investigated, how will the company decide whether it's worthwhile to adopt it or no? I don't know if Artem is hearing it. Yes.
Yes, I'm here. So, could you repeat what the question exactly is?
Yeah. So the question is, let's assume I have a company and I want to adopt the SAFe model. How should I decide whether it's worthwhile to adopt it in my project, or whether it's instead better not to adopt it? So,
Well, it's okay, it's not an easy question because SAFe dedicated for really big companies. It's not like we have a startup and we decided to apply SAFe. It's a bad case. It's really not worth to do it. But in the big companies, yeah, first of all, it should be a decision of the management, of course. They have to make the decision. Yeah, we decide to make transformation, and for the big companies, if they decide to transform to agile culture, actually SAFe one of a few options existing on the market. So either SAFe or maybe less in some specific cases, but SAFe is much more popular framework that still exists. So this is a decision of top management, and well, according to what we could say based on some of our assessments and etc. The decision of top management only is not enough. Well, it do require the full support from lower levels as well, from typical employees. At least they need to understand why are we doing all this stuff. Otherwise it will be a disaster when we'll try to implement it. Just put it directly on the people and claim, okay, you just have to follow these new procedures, and that's all. They will not understand why, they will not value it, so everything will crash.
okay. So any other question from the audience? No? If not, at this point, I would like to thank all the speakers for this very exciting session. Thanks a lot, and see you around. Bye-bye.